Hello everyone. Welcome to this video titled Describe Situations Using Functions. In this video, I'm going to be doing several examples taken from the adaptive practice at a website called ck12.org, and I'll be in their Algebra 1 text. So here we are, ck12.org, in their Algebra 1 text, and the adaptive practice called Describe Situations Using Functions. I will be working through just the first 5 of the 10 of these. Of course, you can go into this site yourself, practice till you get all 10, and then keep practicing even after that to your heart's content. I would recommend that when I start a new example, pause the video and try to work it out yourself, before you see how I'm doing it. Okay, so in this first example, we are asked to write a rule for the function below. So I'm given a table here with inputs called, x values, outputs called the y values. And we see that when the input is 1, the output is 3. When the input is 2, the output is 6. 3 for the input, 9 for the output. And when the input is 4, the output is 12. All right, so we're just asked to look for a pattern here. How is the y coordinate, the y value, related to the x coordinate? So this is just a matter of looking at it and kind of figuring, what is the same relationship for all 4 of these pairs. So what I'm noticing is that, 3 is 3 times 1. 6 is 3 times 2. 9 is 3 times 3, and 12 is 3 times 4. So just looking at this set of 4 ordered pairs here, I would say that the y coordinate is equal to 3 times the x coordinate. So there's really not much to write out here. It's just option D, y equals 3x. I'll check it out. Great. Right. So yeah, not much to do there, just kind of seeing the relationship, how do I take this x coordinate and make this its corresponding y coordinate. All right. Next example. All right. If you bought 6 burgers and each burger cost $10, how much money did you spend? All right. Well, the title of this video, right, the title of this practice is Describe Situations Using Functions. So I'm going to actually pull up the scratch pad here, and we'll describe this situation with an equation or a function like the y equals 3x from the previous example. So I'm going to call the number of burgers, right? This is typically what you do in a lot of mathematical situations. Things that can change, quantities that can change. Usually those are, things that vary, change. You call them a variable. Assign a variable to them. Now the variable can have a long name if you want it to, but typically we're using a single letter to represent a variable. So this number of burgers I decide to eat, that can change. I can decide to eat 1 burger or 2 burgers or 3 burgers, right? That can vary. So I'm going to call this, B for burgers. Now you can call it X or Y or A or C or whatever you want. I'm going to use the letter B for burgers. And then the same thing goes for the, cost. That's also something that can change, that can vary. The cost in dollars. If I eat, 1 burger, that's going to cost $10, right? They said each burger was $10. If I eat 2 burgers, that's 10 and 10, that's $20, right? So the cost can change. I'm going to call that, C for cost. And then over here, we'll write an equation, all right, where we have the cost equals, right, how much does it cost me to eat these B burgers? Well, like I said earlier, it's $10 per burger. So that's a multiplication problem, right? $10 for one, $20 for two, that'd be 2 times 10. $30 for three, that'd be 3 times 10. So it's $10 per burger, multiplied by the number of burgers that you ate. So the relation here, the expression here would be 10b. So the cost of eating B burgers is 10 times B. Now, what we'd be saying here is we'd be saying that the cost is a function of burgers, of the number of burgers, is a function of. You'll see these words a lot. When they say one quantity is a function of some other quantity, that means every value of the second quantity will give me one specific value of the first quantity. All right, so if I say x is a function of y, that means every value of y gives me one value of x, or y is a function of x. Every value of x gives me a one value of y. So when I say cost is a function of burgers, means every number of burgers I choose will give me a single cost, right? So if I were to eat one burger, right, replace B with one, you'd get $10 cost, and that's it, right? There'd be no other cost associated with that. Two burgers, $20. So they're asking when B is 6, obviously this would be 10 times 6, $60 for the cost. So that's choice D here. 6 burgers, $10 each, $60. All right, but I just wanted to show you that when establish a function, one quantity as a function of another quantity. All right, to get it to tie into the title of the adaptive practice a little bit. All right, moving on. Okay. So here, another situation. Each month, you add $20 more to your bank account. If you start off the first month with $100, use the table below to see how much money you will have in the 5th month. All right, now we could easily just say, hey, first month, $100, and then you'll add 20 each month. All right, they're saying you're adding $20 to the bank account each month. So you see how it's 120 in month 2. And then add 20 again for month 3, that'd be 140. Add 20 again for month 4, that'd be 160. And add 20 again for month 5. This is going to be $180 in the bank account in month 5. Once again, I want to use a function. I want to set up an equation, set up a function to describe this situation. So you see we have months and dollars in the bank account. These are things that change over time. These are things that vary over time. So I will represent them with variables. So the number of months that have passed, call that M for months. You can call it X or Y or Z or whatever you want. And I'm going to call it M. So the number of months that have passed. And then each month, the amount of money, right, the amount of dollars in the bank account changes. Anything that changes, anything that varies, we can assign a letter to or an expression to. And I'm going to call this D for dollars. Now, the amount of dollars in the bank account, right, starts off with 100. And then we're adding to that, right? So I got 100 plus, right? I have $100, and then we're adding to that $20 per month. So it'll be $20 times the number of months. I hope that makes sense, right? It's $20 a month times the number of months will be the amount of dollars being added to the 100. So here I have an expression where, we have D equals and then an expression depending on M. I would say that D, using the same terminology, the same wording from the previous example, I would say that D, right, the amount of dollars in the bank account, is a function of, and then the only letter on the right side is M. Right? The only letter that D depends on is M. So the amount of dollars in the bank account is a function of the amount of months that have passed. Right, so each number of months is going to give me, so I input a month number and and it'll give me one output in dollars. Right, every value of M gives me one value of D, exactly one. And they want us to put in, you know, ooh, you know what? If I did it this way, we'd have 100. All right, so let's say the number of months since month one is M. That's so this is the number of months since month one. Let's change that up to actually make this work out. Because if I put in 1 month here, it'll be 120. Whereas, in the first month, there was $100. So in month 5, right, in month 5, then for my formula here, right, in month 5, M will be equal to 4. So it doesn't exactly match the table. But if I plug in 4 here, 20 times 4 is 80, 100 plus 80 is 180, as I said earlier. So a little snafu there, my apologies, but if I count M as the numbers of months since month 1, then we'll have the 180 that I mentioned earlier. Right. Now, if I wanted to have it stick to this, right, maybe I should have had it this way instead. Now, if I called this, just number of months, then I should have had this be 20 times, M minus 1. That way, when I plug in 1, I have the 100 still. So, 20 times the quantity M minus 1. And then I can use 5 for month 5, and this would match the table. Either way, right? Either way, you can set up a formula to represent what's going on here. And then in month 5, right, there are $180 in the account. Right. Okay, next. All right, so once again, we're asked, just like in the first example, to write a relationship between y values and x values. Notice the input of 2 gives me an output of 3. Input of 4 gives me an output of 6. An input of 6 gives me an output of 9. And an input of 8 gives me an output of 12. Now, looking at the choices here, is y equal to 1 more than x? Well, for the first pair, yes, but then it doesn't work for the rest of them, right? 4 plus 1 is 5, not 6. 6 plus 1 is 7, not 9, and so on. Are they 2 more? No, not the first pair doesn't work, right? 2 plus 2 is 4, not 3. Is the y coordinate twice the x coordinate plus 1? No. 2 times x would be 4 when x is 2, and then plus 1 would be 5, not 3. So the only one that's going to be working here is D, right? Y equals 1.5 times x, right? 2 times 1.5 would be 3. 4 times 1.5 is 6, right? 6 times 1.5 is 9. 8 times 1.5 is 12. So we do have D there. Y equals 1.5 times x, right? And then we would also say here that y is a function of x, right? Every x value gives me y, 1y. And when, y is solved for in terms of an expression depending on x, right? So y is a function of x here. Check it out, and it should work out. Yeah. And again, these ones with the tables, kind of, you can run through the choices if you wish, or just think about how to create, the y value from the x value. All right, and I'll do one final example, right, example 5. And once again, it's one of these tables, so I'll just run through it again. Now, looking at the options here, is the y coordinate the x coordinate plus 3? No, 9 plus 3 is 12, not 18. The x coordinate plus 2? No, 3 plus 2 is 5, not 6. Is it 2 times the x coordinate plus 1? No, 2 times 3 is 6, plus 1 would be 7, not 6. So it's got to be this last option. Yet again, the y coordinate here is 2 times the x coordinate, right? 2 times 3 is 6, 2 times 9 is 18, 2 times 11 is 22, 2 times 17 is 34. And that works out. Wonderful. Yeah, so as you've seen, especially in examples 2 and 3, you know, very often you're going to be, given word problems or problems involving words or tables. And there are values that vary, inputs, outputs, months, dollars, numbers of burgers and dollars, or numbers of burgers and costs. Try to identify those quantities that vary, those quantities that change, and call them something. Assign them a letter or some expression, like X or Y or M or B, like I was doing earlier. And then, of course, you're going to have to go back through and try to model the situation as best you can with some sort of equation or inequality or system of equations or system of inequalities, um, that fit the scenario, and use that to help you answer whatever question needs to be answered. All right. And I'm sure in later videos, later on in this Algebra 1 text at ck12.org, we'll see other sections where we use some more word problems and have to set up our own equations and our own inequalities or whatever, after assigning variables to changing quantities, varying quantities. All right. So again, you can work through the rest of this yourself. Even after you're done with the 10 practice questions here, you can go back in and do even more. They'll throw even more at you for more practice. And I would highly recommend, doing as many as you can until you feel like you've totally mastered it, right? You've got it down pat. Right? I hope watching me do just a few of these here helps you out a bit. And thank you very much for watching.